Hello everyone. Today we will be exploring thermal properties of matter, a fundamental topic in physics that helps us understand how heat interacts with different materials. Let's dive in. Thermal properties of matter refer to how a substance behave when they are heated or cooled. This includes how they store heat, change temperature, or even change state, like melting or boiling. Understanding these properties is crucial in everything from designing engines to building houses and even in cooking. Heat and temperature. First, let's clarify two closely related concepts that heat and temperature. Heat is a form of energy that flows from a hotter object to a colder one, measured in joules. Whereas temperature, on the other hand, is measured how cold or hot something is. Specifically, it's the average kinetic energy of the particles in a substance. So heat is energy in transit, while temperature is a property of a substance. Let's come to a specific heat capacity. Different materials require different amounts of heat to change their temperature. That brings us to specific heat capacity. It's defined as the amount of heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. Formula is Q equal to mc delta T, where Q is the heat added, m is the mass, C is the specific heat capacity, and delta T is the temperature that has changed in it. For example, water has a high specific heat capacity, which is why it's used in cooling systems. Change of state. When a substance changes from solid to liquid or liquid to gas, it undergoes a change of state. That means during this process, the temperature stays constant, even though heat is being added or removed. This heat is called latent heat. There are two main types: latent heat of fusion for melting or freezing, and latent heat of vaporization for boiling or condensing. This is why boiling water stays at 100 degrees Celsius until all of it has turned to steam. Then, next we come to the thermal expansion. Now let's talk about thermal expansion. When materials are heated, the particles move faster and tend to occupy more space. This causes expansion. There are three types: linear expansion, that is in length, area expansion, and volume expansion. The formula for linear expansion is delta L is equal to alpha L delta T, where alpha is the coefficient of linear expansion. These concepts are crucial in engineering. For example, bridges have expansion joints to prevent cracking due to temperature change. Then we come to a quick thermal conductivity concept. Next is thermal conductivity. How well a material conducts heat. Metal like copper and aluminium conducts heat quickly, while wood and plastic are poor conductors. That's why they don't conduct electricity faster. The rate of heat flow is given by Fourier's law, that is Q equal to Ka delta T Tt divided by T, where K is the thermal conductivity, A is the area, and delta T is the temperature difference, T is the time, and D is the thickness. So if we come to the some of the daily applications of thermal expansion, thermal properties, these thermal properties have tons of real life applications. We use metals for cooking utensils because they conduct heat efficiently. But insulators like wool or thermocol keep our homes warm. Thermoflasks minimize heat transfer to keep drinks hot or cold. And thermal cameras detect infrared radiation emitted by warm objects. Thank you.